Hi everyone, it's Miss Mulkey here. Today we're going to learn something fabulous about science. I'm going to do a little demo today to show you what happens to gas when we heat it. All right, so in here we have air. There's air particles bouncing around, and as you see, I have a hot water here and I have some cold water. So you can see the steam coming up, so this is quite hot. So I'm going to be placing this plastic bottle into the hot water, and I want you to take a prediction of what you think is going to happen and why. Okay? So you can stop it, write it down in your journal, and then press play again when you're ready. All right, so I put the bottle in the hot water, and as you can see, we have, oh, the alien! All right, so if you predicted that the balloon would go up, okay, then you predicted right. It's also starting to get a little bit bigger. Okay. Now what I'm going to do is I'm going to take this same bottle and I'm going to put it into the cold water. So I'm going to cool down the particles in the bottle, okay, in the gas particles. I'm going to cool them down. So let's see, make a prediction again. What do you think is going to happen? And alien is gone. So what's happening in here? There's a few things that's going on. So if you notice, when I put the bottle into the hot water, it heats up very quickly. The reason that it's heating up quickly is because the gas particles have a weak attraction to each other anyway. So they're already weakly attracted. They don't have a very strong covalent bond holding them together like solids and liquids. So what's going on? Oh wow, it's getting a lot bigger here. So what's going on is that it doesn't take as much heat to heat up the particles as it does, say, with a solid or a liquid. So that's one of the things that's going on. Another thing is, we've been talking about thermal expansion. So the particles, when they get hot, I'm adding thermal energy into them, they start to gain kinetic energy, so they start to move around a lot faster. So when they're starting moving, they're bouncing into each other, so their distance expands. So that would be our thermal expansion. There's also a third thing that's going on here. So if I take, say, a snippet, so I'm taking a little section of this gas, okay, so I have a volume, and I take the same amount of volume and I have it warm it up, my particles, there is a lot less particles in that area that I took. So we have these particles, there's a couple of them, and they're bouncing around when they get warmer. Well, when they get cooler, when I put it into the cooler water, so they cool down the air, and then what happens is the particles then become closer together. They still are moving quickly, they're bouncing around, but not as fast as they do with the warmer air. So this also plays a part with density. Here we have, in the warm one, it is less dense. The particles are not as packed together. Here it is a lot more dense. So when we have the less dense particles, okay, it also rises, okay? So hot air, because it is less dense, it rises. Cold air is more dense, so it sinks, okay? So hot air rises, cold air will sink. And this would, if we took a real life reasoning, thinking about it, we could think about it in our house. If you go into the basement, it's usually a lot colder than it is in the upper floors of the house. And that's because warm air from the furnace will rise and the cold air will sink. Also with a hot air balloon, when you heat up the hot air balloon, that's what causes it to rise. So some real life examples, and I hope you learned a bit more about what's happening to gases when we heat it up. Science is fabulous. Take care.